Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the wavelength and frequency at which the intensity of radiation is a maximum for a black body at 298 Kelvin. So we're dealing with a question where we're asked to solve for the wavelength, which is the lambda, so wavelength. We're supposed to solve for it. And then we're also asked to solve for the frequency, which is this V with the curve at which the intensity of the radiation is a maximum. So we're supposed to solve um, the wavelength and frequency at which the intensity of radiation is at a maximum for a black body at 298 Kelvin. We're also given the temperature. Now, one thing I want to mention that this is a question from the Atkins Physical Chemistry 11th edition textbook, and this part of the question deals with this part of the textbook deals with quantum mechanics. So this is a quantum chemistry slash quantum mechanics question. So the first thing you have to note is that you have to look at the keywords. We're told to calculate the wavelength and frequency at which the intensity of radiation is at a maximum. Now, when you see intensity and you see maximum and you're dealing with black body radiation, what they're actually asking you to use to solve for questions like this is something called the Wend's law. And basically, the Wend's law is, or Wayne's law, whatever you want to call it. So the Wend's law is basically the wavelength at the maximum times the temperature is equal to a value 2.9 times 10 raised to the power of negative 3 meter Kelvin. Of course, you already know that the value for the wavelength at maximum, the unit for that is meters and the unit for temperature is Kelvin, hence why we have meter Kelvin here. So I just wanted to mention that you need the Wind's law, and basically the Wind's law and temperature are inversely proportional. So as the wavelength, or let's just say as the temperature increases, right, the wavelength becomes shorter and shorter, meaning the frequency increases, leading to a higher increase in the intensity of radiation. Now, it's also possible for you to see the it's possible for you to see the formula this way. So wins the intensity at the peak. You already know peak and maximum are basically the same thing. So the formula could also look like this. So just know that you're dealing with the exact same type of question. So I just wanted everyone to be on the same page. They could tell you that the intensity of radiation is at its peak or at its maximum. So yeah, that is basically it. So of course you already know what to do. Is that you've been given temperature at 298 Kelvin and you're supposed to solve for the wavelength at maximum. So wavelength at the maximum is just simply 2.9 times 10 raised to the power of negative 3 meter Kelvin divided by temperature. Now, remember, I was telling you we are told to find the wavelength. What they're actually asking you to is for you to find the maximum wavelength. So basically, lambda max is the same thing as just lambda, at least in this particular question. So the wavelength at the maximum ends up just being 2.9 times 10 raised to the power of negative 3 meter Kelvin divided by 298 Kelvin. And you cancel out the Kelvin. So the wavelength at the maximum is equal to 2.9 times 10 raised to the power of negative 3 divided by 298. When you input this information in your calculator, you end up getting 9.7315 times 10 raised to the power of negative 6 meters. So this is basically the answer. But then again, we are chemists. We have to put our work in the proper number of significant figures. And in order for you to do that, you have to look for the lowest number of significant figures that you use when solving the question. Of course, you can see that the lowest number of sig figs is 2 sig figs. So we're going to put our work in 2 sig figs. So you end up with 9.7 times 10 raised to the power of negative 6 meters. So um this is the lambda at the maximum, or the wavelength at the maximum. So that's basically it. So now we have to solve for the frequency, and the frequency is just this. And it's important for you to know whenever you're dealing with questions like this, that whenever you're dealing with frequency and you've been given the wavelength, you have to use the formula, which just simply says the speed of light c is equal to the wavelength, sorry, is equal to the frequency times the wavelength. So here you're going to end up with the C is equal to the frequency times the wavelength at the maximum. So we're going to end up using this to solve for the frequency. So frequency ends up becoming C, which is the speed of light divided by the lambda at the maximum. Now, let us, before we do any form of substitution, we have to note that C is speed of light. So it is basically 2.998 times 10 raised to the power of 8 meter per second, right? And then, of course, the maximum wavelength is 9.7315 times 10 raised to the power of negative 3 meters. So now we've got frequency is now equal to 2.998 times 10 raised to the power of 8 meter per second divided by 9.7315 times 10 raised to the power of negative 6 meters. And of course, you cancel out the meters. So the wavelength, so the frequency becomes 2.998 times 10 raised to the power of 8 divided by 9.7315 times 10 raised to the power of negative 6. So that ends up becoming 3.08072 times 10 raised to the power of 13 seconds minus 1, or seconds raised to the power of minus 1. Or you can just simply say the frequency is equal to 3.08072 times 10 raised to the power of 13 divided by seconds. This is just telling you that, like, we have 3.08072 times 10 raised to the power of 13 um per second, cycles per second, because basically frequency's definition is frequency definition is basically how many cycles per second. So basically the frequency, I'm going to put in three sig figs because we want to answer in three sig figs, is going to simply be 3.08 times 10 raised to the power of 13 per second, or second raised to the power of negative 1. And this is basically the answer to this question. If you have any question, please put in the comment section. If you need any help with tutoring, you can email me at shohabi@gmail.com. I help students succeed in all aspects of academia, especially relating to STEM, as well as mentoring. So I help students in middle school, high school, and college to succeed in all your STEM related courses. And if you would like to book a session with me, make sure you email me at shohabitutoring@gmail.com. I wish you guys all the very best. Do not forget, if you have any questions, concerns, and suggestions, to put it in the comment section. Assalamu alaikum wa rahmatullahi wa barakatuh.